90% of the surface of this planet is covered by water. India has a meager 4%. It means that India has a 16% share of the world's population, but hardly any share of the world's water sources. India is dealing with severe water scarcity. The World Bank estimates that about 114 million Indians will soon face desperate domestic, agricultural and industrial water shortage. It's one of the largest crises facing India in terms of spread and severity, affecting 1 in every 3 Indians. I'm Manvi Dhillon and you're watching DuPont Presents The Power of Shunya-Quest for Zero. And today we're on a quest for zero water shortage. We'll examine India's water challenge from a few different perspectives to first determine how we can save the scarce water resources we have, and second, to see how we can adapt our farming techniques to cope with the reality of depleting water resources. For deeper insight into the causes and consequences of the water crisis in India, let's speak to Professor Krishna Achyuta Rao of IIT Delhi, a man who's observed the changing hydrological cycle in India for years. He understands water in the Indian context truly and deeply. Professor Rao, thank you very much for joining us.
Thank you.
In simple terms, how acute is the water shortage in India today?
I think it's a regional problem in terms of there are some places which are probably doing fine. There are some places which are clearly under some stress, I would say, and there are problems that are looming.
I'm going to ask yet another simplistic question. If you had to categorize the causes for the stress in water in pockets of India, what are the primary causes that come to your mind?
One of the key things, of course, is the vagaries of weather, the climate as it varies, both naturally and more recently due to man-made climate change. But beyond that, there are also issues with overexploitation of water resources, poor management practices, a lot of pollution, a lot of just degradation of the kind of available resources.
What are the policies and measures in place today in India that really are thinking about our water crisis, that are addressing our water crisis?
This is going to have to be addressed, and whether it's through conservation, which is trying to make more efficient use of the water and therefore use less of it, or through managing it better, because a lot of water is just wasted and misused.
Conservation is a huge part of the approach, but the other part, and I just wanted your thoughts on that, is adapting to the realities of water shortage, rethinking our assumptions on water availability. Do you think there's enough emphasis on the latter?
There are people who are aware that you will need crops that will be resilient to different temperatures or different availability of water or different quality of water, and whether you'll have to make do with sort of brackish water. So there are people working on developing new sorts of crops that would thrive in these conditions.
Summer in India means unrelenting heat. Long queues for water tankers as temperatures soar. That's a common sight across many of our cities. Our groundwater levels are falling every month. This despite the fact that many parts of India receive good rainfall. So what's the solution? Well, if you were to ask Ayappa Masagi's Water Literacy Foundation, they tell us we all know the answer to the problem. In fact, Ayappa Masagi, known as the water warrior, is credited with returning to the fundamentals of water conservation. And he's influencing agriculture, industries, private homes, and many more. Let's see how. Less than 3% of the world's water is fresh. The rest is seawater. 2.5% of that 3% is frozen. The entire humanity is dependent on 0.5% of fresh water. Majority of that fresh water is stored in underground aquifers, but our growing demands and low rainfall are running these water mines dry. This caused a stream of water troubles for companies like Karnataka Antibiotics and Pharmaceuticals Limited in Bangalore until they employed the help of Ayappa Masagi.
We require a lot of water for our processes, maybe to the extent of about a lakh of liter a day. So, in fact, initially we sourced this particular water through bore wells. Due to the increased industrial activity over this area, the bore well started slowly getting dry. So, in fact, we were forced to buy water from outside through tankers, etc.
What's changed in terms of functioning, in terms of access to water?
As against the normal availability of water at the depth of say 600, 700 feet, we could see water at about 169, 170 feet. Second thing is, of course, our sourcing of water from outside tankers are reduced by and large. And we are able to use our own borewell waters for our protection purposes and various other needs. So that's the change we are seeing post Mr. Masagi's involvement in our rainwater harvesting.
What makes Masagi's approach unique is the fact that unlike current rainwater harvesting techniques that concentrate on collection and storage, his methods recharge the groundwater first with filtered rainwater, equipping us with a system for zero water shortage. One rainwater harvesting system is under construction here at Karnataka Antibiotics.
Yes, ma'am.
What is the model that you're applying here? What are you doing here?
Yeah, here some type of you have three components. One is collection.
Okay, so is the collection happening
Yeah,
there?
collection there actually coming from the drainage. We have trapped all 4-5 acres of runoff, even roof rainwater, road water, all water actually collecting in that is called pre-silt up tank. 50% of the sediments will settle in the tank.
Okay.
Then 60-50% filter water coming and collecting. This will look like sump, no? Is collecting.
Yeah.
Here also actually started percolating and sedimenting. Start sediment. Then you have second, another third stage. This is called actually gallery type filtration unit, or you call it the gallery. So this gallery made up of stones, bare stones. See here, no cements, jelly, sand, pebbles they are using. All the water, that 50-60% filter water pass through. Then again coming here, this system is called storage point.
Okay.
Here bore is the storage point. The tube is connected surface to your groundwater aquifers.
Okay.
So here again the last sixth stage, we are going to make a holes and casing.
Okay.
Over that we are going to put a 4 to 5 layers of plastic netlam.
Right.
Then forest for motor I am going to inject into the ground through this casing.
You're a mechanical engineer, so explain the science behind what you're doing here.
Yeah, I'm actually a science I'm using here. Actually, I'm charging all the 4 water. Have a total of 4 waters: subsurface water, subsoil water, deep soil water, groundwater.
And these methods are yielding huge returns for farmers like Murugappa, who depend on bore wells for irrigating their crop. When the groundwater dried up, Murugappa invested in Masagi's lake-type bore well recharging method.
I found a huge catchment area, and all the catchment areas runoff actually passing through his besides his land. Then I decided to construct a lake. Here actually the lake is very huge catchment. If you harvest the total catchment area, if you harvest 5%, to harvest I designed for only 5% water for runoff. So 60 meter by 40 meter, then I go for 4 meter depth. Then immediately agree. Then I constructed a lake. Once the lake full, actually nearby the lake, one bore was there, actually existing bore well. There we done actually H-type bore well recharge. One system called H-type bore well recharge. Totally 6, 7, 8 feet no one rises. All the water directly, instead of going into the drainage or somewhere else, it going into bore wells, directly injecting into the aquifers now. In my experience already, so 1 kilometer up to 3 kilometer radius already charged actually after 1 year or 2 years.
Murugappa is now a happy man. Within 3 months of getting the work done, he can already see the results.
ಸರ್ ಖಂಡಿತ ಉಳಿಸ್ಬೋದು. ಆಗ ನಮಗೆ ನೀರಿಲ್ಲ ಸಮಯದಲ್ಲಿ ಟ್ಯಾಂಕರಲ್ಲಿ ಒಂದು ಟ್ಯಾಂಕರ್ ನೀರಿಗೆ 500 ರಿಂದ 600 ರೂಪಾಯಿ ತಗೊಳ್ತಾರೆ. ಅದರಲ್ಲಿ 3,500 ರಿಂದ 4,000 ಲೀಟರ್ ನೀರು ಬರುತ್ತೆ. ಈಗ ನಮಗೆ ನಮ್ಮ ಬೋರಲ್ಲೇ 1 ಅವರ್ಗೆ ಅಷ್ಟು ನೀರು ಬರುತ್ತಲ್ಲ, ಖಂಡಿತ ಉಳಿಸ್ಬೋದು ಸರ್, ಏನು ತೊಂದರೆ ಇಲ್ಲ.
ಎಷ್ಟು ದುಡ್ಡು ಉಳಿಸಿದ್ದೀರಾ ಅಂತ ನಿಮ್ಗೆ ಅನ್ಸುತ್ತೆ ಇಲ್ಲಿವರೆಗೂ?
ಸರ್ ಇಲ್ಲಿವರೆಗೂ ಅಂದರೆ ಸುಮಾರು ಒಂದು 2 ಲಕ್ಷ ರೂಪಾಯಿ ಆಗುತ್ತೆ ಸರ್ ನೀರಿಗೆ
ತಿಂಗಳಿಗೆ. 2 ಲಕ್ಷ ರೂಪಾಯಿ ತನಕ
ದುಡ್ಡಿಗೆ ಉಳಿಸಿದ್ದೀವಿ ಅಂತ ಅನಿಸುತ್ತೆ ಸರ್ ನಮ್ಮ ಪ್ರಕಾರ.
Dubbed as the groundwater hunter, Masagi has successfully implemented most of his methods at more than 5,000 locations, taking us one step closer to zero water shortage with each raindrop. While our first innovation helps farmers overcome the unpredictability of water resources, our next technology shows how by adopting a new approach to farming, groups of farmers can adapt to changing water levels in a region. Stay tuned. Globally, agriculture accounts for 70% of all water consumption. It's no different in India, where the largest chunk of water goes to agriculture. Unfortunately, in parts of the country, overpumping of water for agricultural purposes is resulting in depleting groundwater levels. As demands multiply, less water is available for irrigation. There's no doubt that farmers must adopt smart irrigation practices. But did you know that farmers can strategically choose the crops they harvest and the seeds they plant to meet the challenges associated with water shortages? Come meet a community of farmers who are adopting new varieties of crop that increase yield and income without draining their water resources. Lush green fields, a bountiful harvest, and a bumper crop. That's a dream that unites farmers all across India. But in water-starved Punjab, it's a struggle to grow the state's mainstay, paddy. While in rural Telangana, erratic rainfall wreaks havoc on crops. Water is a critical lifeline in sustaining agriculture in India.
ਜਦੋਂ ਪੈਡੀ ਨੂੰ ਸ਼ੁਰੂ ਦੇ ਵਿੱਚ ਇਹਨੂੰ ਆਪਾਂ ਨੇ ਨਰਸਰੀ ਤੋਂ ਪੱਟ ਕੇ ਇਹਦੇ ਖੇਤ ਦੇ ਵਿੱਚ ਲਗਾਉਣਾ ਜੀ, ਇਹ ਤੋਂ 12 ਤੋਂ 14 ਘੰਟੇ 1 ਏਕੜ 'ਚ ਪਾਣੀ ਪੈਂਦਾ ਹੈ, ਲਗਭਗ ਅੱਧਾ ਫੀਟ ਕਿਊਸਕ ਪਾਣੀ ਦੇ ਵਿੱਚ ਖੜਦਾ ਹੈ। ਤਾਂ ਦੇਖੋ ਤੁਸੀਂ ਅੰਦਾਜ਼ਾ ਲਗਾਓ ਇਹਦਾ ਵੀ ਕਿੰਨਾ ਜ਼ਿਆਦਾ ਨੁਕਸਾਨ ਪਾਣੀ ਦਾ ਹੋ ਰਿਹਾ ਹੈ।
Last year I put the etc. hybrid seed. Rain come 2 or 3 days late, and again I give water. It will be growth, but bacteria attacked. Here to there, 4 or 5 pieces is dead.
An idea and a seed can kickstart a revolution. And DuPont Pioneer, through its understanding of complex geographies across India, is helping farmers overcome the challenge of water shortage in farming. We're here in the heart of rural Telangana, North Telangana, what everyone knew until recently as Andhra Pradesh. Let's focus on the farmers here and what they're going through, and another set of farmers that you work closely with, which is the farmers in Punjab. What are they experiencing right now?
The biggest challenge that the farmers in Punjab face today is the water table. It is falling day by day, and rice and wheat being key crops for the farmer in Punjab, it is becoming increasingly difficult for them to manage, especially the rice which grows in the rainy season with the kind of water that they have. So their big challenge is now to look for an alternate to rice. Coming back to Telangana, the monsoon has arrived one full 1 month late. Normally when I travel during this time in this area, I see normal crop to be this height, and and what exactly you find in most of the areas is like this today. So which means that, you know, farmer really does not know how would he, you know, grow up his crops this time. So it's the monsoon vagaries that are kind of big concern for him.
With hybrid seed varieties specially designed for different areas in India, farmers in Punjab and Telangana are battling water wars. Farmers in Punjab are diversifying from rice to DuPont Pioneer hybrid corn P3396. And in Telangana, they are upgrading to the hybrid corn variety P3502. Here we are standing in the middle of a field, I suspect surrounded by the DuPont Pioneer P3502 seed. But I want to know, what is the DuPont Pioneer P3502 seed? I mean, what are its characteristics? What is this seed all about?
P3502, it's like, you know, a corn plant that would pull less water from the ground and would survive, you know, with lesser water inside the plant. And, you know, it performs even better if the situations are dry. So it has, you know, that capacity to withhold itself under moisture stress. And all that happens because, you know, you see here the root system. P3502 has, I think, one of the best root systems that you can find in any hybrid corn. This profuse root system allows it to fetch water from, you know, the far off places within the soil zone, even if there is very less water.
Both for farmers in Telangana and Punjab, the rich harvest in their fields tells the story.
ਜਿਹੜੀ 3396 ਹੈ ਵੈਰਾਈਟੀ ਪਾਇਨਰ ਦੀ ਡੂਪੌਂਡ, ਇਹਦੇ ਵਿੱਚ ਸਮਾਂ ਬਹੁਤ ਕਮ ਲੱਗਦਾ ਜੀ, 90 ਤੋਂ 95 ਦਿਨ, ਤੇ ਕੀਟਨਾਸ਼ਕ ਦਵਾਈਆਂ ਦੀ ਵੀ ਵਰਤੋਂ ਘੱਟ ਹੁੰਦੀ ਹੈ, ਤੇ ਜੋ ਮੇਜਰ ਪ੍ਰੋਬਲਮ ਹੈ ਵਾਟਰ ਕੀ, ਉਹ ਬਹੁਤ ਨੁਕਸਾਨ ਹੁੰਦਾ ਹੈ ਵਾਟਰ ਲੈਵਲ ਦਾ, ਉਹ ਨਾ ਮਾਤਰ ਹੀ ਇਹਦੇ ਨਾਲ ਲੱਗਦੀ ਹੈ, ਉਹ ਸ਼ੂਨਿਆ ਦੀ ਤਰਫੇ ਜਾ ਰਹੀ ਹੈ.
This P3502, last year I experienced this one so much water I give the so much one. And this year last 1 month no have rain. We are difficulty seasons. Current also don't have. We have water also get less. So this one giving 1 week or 10 days either. This one giving the water. But this crop see you good one.
With the aim of minimal water waste in fields of India and maximizing crop yield, DuPont Pioneer hybrid seeds are indeed on a quest for Shunya. We're back with Professor Krishna Achyuta Rao to discuss India's water issues in the context of Indian agriculture specifically. You've seen Ayappa Masagi's water conservation methods. How far do you think they'll go in really helping an Indian farmer?
I think as long as farmers are able to take on some of these practices, implement it within their farms or villages, I think it's going to be useful for them to have a sense of control and a sense of owning of that resource, so that they can use it better.
We've seen another innovation which really focuses on hybrid seeds that produce increased yield, require less water. Is hybrid seeds also the future, in a sense, the way forward for Indian agriculture? Because A, it increases yield, B, it requires less water.
Right. So there are clearly connections to how much of the water you have to use up to grow these crops, and whether it's the quantity of water, or whether you're making these new hybrid seeds to be resilient to poor quality water. So hybrid seeds would be, especially as they pertain to water use and temperature resilience, these are going to be very important for the future.
How important is innovation today, in the future, to ensure that the Indian farmer actually gets maximum yield given the scarce sort of input resources?
Right. Underlying all of this is of course our need for food security, and you can't compromise on that. You can't say we will produce less because we have less water. You still need the food. So anything that you're able to do with the science or technological innovations to keep your yields up, maybe even raise them further, is absolutely essential.
Unsustainable agriculture harms our environment by sucking our water bodies and underground water resources dry. It means that agriculture, the largest industry in the world, is also a large threat to our environment. On the show today, we've seen two innovations. One that aims to minimize water poverty, another that aims to maximize food production. India must continue to pursue innovations that aim to achieve water security and food security. That's it on this edition of DuPont Presents The Power of Shunya-Quest for Zero, a show that celebrates science and innovation, technologies that could secure our future, human ingenuity that could reduce our challenges to zero. Till next week then, goodbye.